This tutorial will deal with quick conditions in soil mass, and we will see how we can solve some practical problems. We'll start with this one when we have a very thick layer of clay. Clay is saturated, and the density of clay is 1.7 grams per cubic centimeters. On top of the clay layer, we have 4 meters of water, which is lake. And below the clay, we have a layer of sand, and sand is under artesian pressure. We know this because when we drill borehole, the water level will rise very high, and it will be at a level which is higher than the current level in the lake. And what we need to find out, if we drain the lake, let's assume that the water level in the lake will go down by maybe value h to this point. So at what level of h, at what number of h, there will be quick conditions in the clay. So whatever happens is going to happen in the soil mass, in the clay. Okay, so I think we'll first start with, there are different ways to do this problem. So the one that we're going to use is related to critical hydraulic gradient. So critical hydraulic gradient can be defined through specific gravity and void ratio. Or another way to find critical hydraulic gradient is through unit weight. So we need to know the unit weight of soil that is saturated and unit weight of water that we know. In our case, we are given density 1.7 grams per cubic centimeters, so we can easily obtain the unit weight of soil. That's why we're going to use this equation. Why do we use critical hydraulic gradient is that we know for sure when the hydraulic gradient that is currently in the soil mass, when it reaches its critical value, there will be liquefaction or quick conditions. So what we need to find, well, first we can find the hydraulic gradient, current hydraulic gradient in the soil, and the definition is delta H divided by L. So we need to understand that this additional upward seepage, it starts from the bottom of the clay layer and then it goes all the way to the top. So that's when we have all the seepage here. So you know that seepage can only be possible in soil layer. There is no seepage in lake, in water. So in this case, we're going to find delta H. And to find delta H, we need to take the difference between two water levels. So the easiest way is to find water levels. So this is the first one, number 2. So the difference will be 5 minus 4, which is 1 meter. And then we will divide by the distance. So we're dealing with the whole layer of clay from here till here. So this will be L. Which is 6. So it's going to be 1 over 6. Now what we're going to do next is we'll find the critical hydraulic gradient for this layer of clay. And we're going to use this equation as already mentioned. So first we need to find the unit weight of clay. So it's density times G. In this case is going to be 1.7 times 9.81 will give us approximately 16.7 kilonewton per cubic meters. Now we're going to find critical hydraulic gradient, which is 16.7 minus 9.81, which is the unit weight of water, divided by 9.81. Will give us approximately 0.7. So the quick conditions may occur in this clay layer when its hydraulic gradient equal to its critical value and is equal to 0.7. So what we can do right now, we can rewrite the equation for hydraulic gradient for the clay layer as delta H divided by 6, and it's equal to 0.7. So now we're going to find this delta H. We know that for the current situation, before we drain the lake, the delta H is equal to 1. We already found this one. And when we drain the lake, the water level will go down by a value of H. So what we can do is we can rewrite this equation as 1, which is the current delta H plus X, because we drain the water in the lake. We still have the same thickness of clay layer, which is 6. And we know that critical hydraulic gradient for this clay is 0.7. When we solve this equation, we're going to find that X is approximately 3.2 meters. And if the current level is 4 meters, so the level of water in the lake at which liquefaction or quicker conditions would happen will be 4 minus 3.2 meters. It will be 0.8 meters. So this means that when water level goes all the way down till here, and this is 0.8 meters. So in this case, there will be liquefaction in the clay soil.